I know we had the joke about how it's going to be all cold and icy now. Well, it is going to get a bit cold and icy, but before that, I want to get a maybe by raise of hands, how many of us here have worked with some form of LLMs or generative AI models? Anything LLM, anything Gen AI, of course. Has to be all of us because why else are we here? And say how many of us have built a chatbot-like interface or like any chatbot-like app? Okay. Prompt engineering? Yes. Fine-tuning? Awesome. So I am talking to all the right audience at the right topic, so that's fantastic. But how many of us have worked with Snowflake before? Amazing. Okay. A lot of reassurance. Today, I'm going to talk about how to fine-tune your LLMs using Snowpark container services. And then we'll follow up with how to actually evaluate these fine-tuned models using WNB, weights and biases. And a big shout out to the team today. I guess we had the announcement of Weave, which is going to help us exactly with that, kind of transitioning us from ML ops to the LLM ops side of the story. And yeah, so that's pretty much it. That's all we're going to talk about today. And I also have a live demo at the end of it. So y'all should start praying already to the demo guards how it's going to go today. Right? All right, a quick bit of intro about me. I started off as a software engineer and then got into this AI ML space very much coincidentally and then ended up loving it. And now currently I work as a developer advocate at Snowflake, primarily focusing on data engineering and large language model workloads. That's kind of why I'm here today. And I am Vino, and these are the different mediums in which I write and like share my learnings mostly. And before I go on and on about what are the challenges and what do I write about, let's dive right into what Snowflake is, what are its capabilities in AI and generative AI and LLMs today, and how do we actually see the Snowflake platform, right? So when it started out, and it's even till today is a pet peeve of me when people talk about Snowflake being a data warehouse, and I'm like, sorry, that's like 5 years ago. And 5 years in today's age, specifically in the AI space, is like almost a century old. So I'm like, please don't give me the data warehouse lingo anymore. So we are a data and AI platform with tons of offerings. Today, we are going to specifically talk about the LLM and the generative AI offering. As you can see here, covering the spectrum of it, right? Because some of us started out as SQL and data analysts and then evolved into the data and the ML and the AI side of things. Some of us came in from, say, DevOps and the infrastructure side of it, working with containers like Dockers and other stuff, managing the data infrastructure. And then some of us come in from the ML engineering side of it, building models for data science and the different business use cases. But then AI coming in is changing all of our jobs today, whether you accept it or not. So how do we cater to this entire spectrum of data and data science practitioners with AI, right? For that, Snowflake, for example, has some offerings which are straight out of the box. Say if you are using Document AI or Cortex serverless SQL LLM functions, you don't have to do a thing. You don't need to know what an epoch is, what an iteration is, how a model is being trained. Nobody cares. Say when you're writing a SQL function today, how many times do we use the min and the max and the average and the sum functions? Do we even think about how is this min function implemented under the hood or how is average being implemented under the hood? Not really, right? Imagine having the power of LLM functions doing the same within a SQL query, doing the same thing for you. For example, I will show you working examples later, but the idea is you will have, say, a translate function as part of a SQL query. So a data analyst today will still be able to use these generative AI and LLM capabilities for their business use cases without having to really juggle through different hurdles and jump through the hoops to get there. And we have universal search, again, coming in from like the acquisition of Neeva and the search capabilities of Neeva coming into Snowflake, for example, is today when you are looking at search, you can say within Snowflake, imagine having the capability to search for a table or any other object or even a specific app that is being listed in a Snowflake marketplace. all of that coming together in one specific or like one search option, that's like game changing. And Snowflake Copilot, if you were there at the keynote today, Vivek talked about how we built the Snowflake Copilot and what were the challenges the AI research team had like gone through it and all of that. And we also have Streamlit, like Streamlit as part of the Snowflake, how it helps you build the UI or like the app layer for any of these AI applications. All of them sit on top of Cortex. Snowflake Cortex is this one big, massive LLM offering that has the serverless, LLM functions, search, and the UI or the app layer, all of that sitting on top. But again, all of these are for, say, out of the box, or how do I get started with AI in a couple minutes, couple seconds, done, right? But what if, on the other end of the spectrum, there are people and there are enterprises who want to build their own custom or like fine-tuning of models or build their own proprietary foundational model from scratch? How does Snowflake help them? Which is where, part of what we're going to talk about comes in. How do you fine-tune an existing foundation model with your own enterprise data? Because again, as we all think about AI is coming for all of us, but the only biggest moat for all of our companies are going to be the proprietary data that we have. So how do you leverage that proprietary custom data for building a competitive edge in the AI game is how you can now say fine-tune your own foundation models version with the enterprise data. You have GPU compute coming in through container services and all of that, which we'll probably see later as well. Now, when I'm thinking about fine-tuning, you also need an option to fine-tune with the models that are available in the open source, say, Llama and the Mistrals and the Gemmas of the world, right? So that is also possible with container services, and you will have access to any of these open source models within Snowflake as well. I guess we've talked enough about Cortex. I'm just skipping through some of these slides. Okay, so this was that one example that I mentioned, how you can use these serverless LLM functions as part of a SQL query without having to think too much about how they work under the hood. So a SQL person can literally write a query to translate any text data that's coming in, and then they will treat this like just any other column. And this is super powerful. And you have summarize and extract answers and other specific functions within Cortex as well. And we also have a complete function, which is a more generic chat completion equivalent in SQL. And as you can see here are the list of some of the models that are supported today in Cortex. All good. I'm skipping through this. Yes, so Document AI is another powerful solution, again, built on Snowflake Cortex, where from unstructured PDF documents, and if you specifically come from industries that deal with a lot of contractual PDF documents, you will realize how valuable this is. We're extracting entities from unstructured PDF documents and, in fact, storing them in Snowflake tables and, putting them to use for downstream, analytics applications is very powerful, and it is also one of the Cortex offerings as well. Again, all of that we talked about are very, how do you get started in minutes and seconds? Like one level further is how do you build a RAG? Today, if you have all of your data sitting in Snowflake, for example, Snowflake supports vector data type, which means you can store vector embeddings within Snowflake. And now we also have, like a couple of days ago, we announced and released this Arctic family of models, which can do embeddings, like text embeddings. So you can actually embed the text using those functions. And now you also have Snowpark container services that gives you GPU compute. So you can build this entire end-to-end RAG model from within Snowflake without having to use anything external at all. So when you think about this whole LLMs and like the LLM ops space, there is like hundreds of tools that we're working with. For this one specific use case, you need this one. And for this specific use case, the LLM stack becomes humongous and kind of becomes unmanageable at some point. So which tool are you supposed to learn when? But when you have something like Snowflake, an AI platform that gives you this end-to-end offering, end-to-end RAG is kind of super easy and feasible in Snowflake. And Copilot, I guess we all know how a Copilot works, and we also saw Vivek dive in detail about this, so I'm going to skip over this as well. All right, enough about the generic offerings. Let's dive right into what we're here for today, which is like fine-tuning Llama 2 with my own custom data set that I have in Snowflake. So let's dive in there. Awesome. So this is a broader architectural view of what the demo is going to be today, right? So if you think about it, in my local, I have a Docker image, which will have specs of, what actually am I going to be using. We will go over the Docker image specs as well in a bit. And then I have the specs YAML. The Snowpark container services, if you want to, build a mental model, you could imagine that more like a Docker container, right? So within Snowflake, you have this Docker container that has GPU compute available. So all you need is that a specific, a spec file, and then you upload the spec file, spin up the container, and you have the GPU compute. So you can download this Llama 2 model from Hugging Face and then start fine-tuning it from the Snowflake data that is sitting in a specific table. And as you see here, once you are able to spin up that container, we will have a service, like a service run from this container. This is the service that is going to serve as your endpoint for the fine-tuned model, inference endpoint. And that's pretty much it, as you see here. And before I even went any further, let's dive into the Snowflake side of the world. First, what I have is within, not sure if it's going to be visible for all of us, trying to zoom in as much as I can. And as you see here, all good? OK. A bunch of, the setup. OK, so the setup has a bunch of, creating all these different roles that we need to actually run through the demo. So we should be good with that. And the most important thing that I want us to focus here is that we are fine-tuning Llama 2 in Snowflake. You will not see anything other than SQL code in this entire thing. Imagine the power of a data analyst being able to do all of that within a couple of bunch of SQL queries. That is what I want to take you away from this talk. You can, of course, do all of this from Python as well. We also have Python API equivalent of this. But today, for this demo, it's all going to be in SQL. So the one thing that I want us to focus here is that after setting up all the configs and the roles and the databases and the schemas that you need for this, where is this? So I am creating an external access integration, which is, so when I'm accessing Llama 2, my Llama 2 is not sitting already in Snowflake, right? It is in Hugging Face, hosted from Hugging Face. So I set up this external access integration from Snowflake account to Hugging Face to be able to access the Llama 2 model, right, within. So which is what I'm doing here. And once I have that, I'm just creating the compute pool. This is the GPU compute I need to actually fine-tune this model. That's it. And so my compute is active and running, all good. That's pretty much all we're doing, right? Spin up a container and like a GPU compute, and then set up external access integration. Now, in the training data, if you see here, oh my gosh. OK. It's again a two-step simple process. Perhaps I should show you what the data looks like before I even do that. So this is the product offers data that I have. It has a bunch of columns as to link to the product and what product category and description and name and qualification and all of that is. And this is the data I'm going to use to fine-tune Llama 2, which is, if you look at it here, is just about product offers data set. If you're a salesperson working for a specific company, you have details about all these different products. And what I'm trying to now train Llama 2 is I'm going to fine-tune that to act as like a sales representative, where you tell a specific product, and the sales rep will tell you what are the different offers associated with that specific product, right? Which Llama 2 as in itself will not be able to effectively do it. So we're going to fine-tune it with this specific data. Now, this is what the data set looks like. But for my fine-tuning process, if you see in the training data, what I'm doing is I'm reading the data from the product offers table and all the different columns into an unstructured text file. It's just making it into a text blob where this is the company offering this reward for this specific type of a product category and what qualifies it and everything. Basically, I'm taking all these 7, 8 different columns of data and blobbing them together into just one big chunk of text, which I can then pass on to the model for fine-tuning, right? So I do that, and I'm copying that. So this is the training table, and if I can maybe go back and look at what the training table's content looks like, you will get an idea. So it only has one column, which is text, and in that column, what it has is that, it has a bit of instructions on what the actual model is supposed to do, and followed by all the different columns of data that we have. That's pretty much it. Like, this is how we have prepped the data. We didn't do a lot of pre-processing or cleaning up or anything at all. We just took the data and blobbed them into just one big chunk of text, and we will pass this text onto the model for the fine-tuning process. Now, here comes the main, this is probably what, this 20, 25 lines of code is where you are actually fine-tuning the model. So I'm just using the specific role, database, and schema here. And now I'm creating a service from the Docker container, or the Docker image that I uploaded to the Snowpark container services. And when I'm creating the service called AutoTrain using this compute pool from the specs file that we would have already uploaded, I will go to the specs file in a bit. And how many service instances do I want? I just need one because I'm just showing a demo here. I don't want it to scale depending on the load and all of that. I've already created an external access integration to access the Hugging Face's Llama 2 as well. And that's pretty much it. This line right here is what is creating this fine-tuning job for you in a Docker container or in a Snowpark container within Snowflake. And now let's look at what does this auto train look like and what are the specs that is even in there, right? This is literally it. So as you look at the specs in here, just the name of an image and all the secrets that I've used to configure the external access integration to Hugging Face. So I've used my Hugging Face token, and what is the model that I want to literally read from Hugging Face? It's going to be Llama 2 7 billion one, and I'm just going to give a custom name for the fine-tuned model that I'm going to use, and then we will take 2 GPUs, and we would create a volume mount in the Snowflake stage to kind of dump this fine-tuned model in the end. And just 2 different endpoints. One is a Jupyter notebook and another is a Gradio app for me to interact with the fine-tuned model in the end as well. So this is pretty straightforward, and literally all you need is this spec file, and then you create the service and you're good to fine-tune, right? Again, in a 2-line command, essentially, you're able to fine-tune a Llama 2 with your own custom data in Snowflake. Okay, so this is the service, and I wanted to check if the service is running, and I hope and pray that it is. Okay, now let me look at the endpoints. I think it should be all the same. So the Jupyter and the app endpoint, and I'm going to the app endpoint, which I already have it open. Let me just clear the history. I hope you're all able to see it. And as you can see, I have 2 models here. The 7 billion one is the model as is that I got from Hugging Face. And then the FT is the fine-tuned one that we got from, the fine-tuned one from Snowflake. And now, if you also look at the instructions, right, the one that we used in the fine-tuning data set, you're a customer service assistant with the knowledge of product rewards, and these are the details. So what I'm saying is I will give the details of the product in a certain format, and the customer service representative will tell me what the product offers are. And say if I give an example like this, let me just, Okay, first let's try it with the unfine-tuned, the foundation model Llama 2 as is. Unfine-tuned, is that even a word? But I think it's allowed today. Anyway, so I have this specific thing where I give the input or the prompt in a specific JSON format, asking what is the offer, will the model be able to give or make sense of this, right? We will see if it is. So clearly, I don't think it is doing a good job of summarizing what the product offer is about. It's just, it just went on and on until it timed out. So again, Llama 2, for example, if I'd asked a simpler, like a natural language question, it may have answered me properly. But then for this specific input format that I'm giving and expecting it to understand, it won't be able to because it's not trained for that. That's the whole point of it. But this is exactly what we did with our model, where if I give this specific input prompt with this format, it would still be able to make sense of it and then give me this a summary or the description of what the product offer would look like. So when I give the same thing, for example, to the fine-tuned one, okay, not bad. So it is giving a quick summary of what the specific product is about, and to receive the reward, what should I be doing? And clearly, so much better than the model that was not fine-tuned. That's the whole point of it. Again, this was all for the purpose of a demo. I just put together, you can say this is the hello world of fine-tuning an open source foundation model, right? Because we didn't do anything fancy. I used auto-train, Hugging Face's auto-train to do this because we don't want to get into the details of what makes it, how do we actually optimize this whole, fine-tuning process in itself. But this is, again, when we're thinking about fine-tuning, it's always an experimentation. And if there is one thing that has not changed between the traditional ML and the large language models, it is that ML training in any world is non-linear. So there is a lot of back and forth and experimentation that's going on. And what we've done here is that we have one model that is not fine-tuned, and we have one model that is fine-tuned. But how do we know what is better? And how do we even know, how can we even compare these things? Because I can't keep typing and copying, pasting, and playing around with all these values like the good old days, right? Nobody wants to deal with that. Which is where the weave comes right in and fits perfectly in here, because I'm not sure if, how many of you had a chance to go over the W&B weave demo, to see the weave demo. But what it does is it captures the pairs, meaning the prompt response pair for every single query to these models are being captured. And what you can do one step further is, why do you just want to display it in the app and just capture it? Why can't you write it back to Snowflake into a table? Now you have a table with all the input responses and the corresponding, input prompts and the corresponding responses that you got from the models. Now you can use, say, similarity scores, for example, to try and understand how similar are these model outputs. Are they even giving relevant outputs to the same queries? So which model is going to be more efficient than the other? You can do all sorts of different kinds of evaluations, build your own custom evaluation framework. The opportunities of how you can actually evaluate these model responses or model performances are endless, but only if you know what metric and what do you want to optimize for. But the idea is, this is just one workflow, and then in a real world setting, when you're building this for an enterprise, you would be going back and forth multiple times, which is where container services to easily spin up and fine-tune a model, and then weave to coexist together to operationalize this whole experimentation come together. And I think that's pretty much all I had for the talk and demo. And there's one, okay, so we did this already, so the demo time is done. One big call out for Dev Day. I know all of us here are data and AI practitioners. Snowflake's annual developer conference, the Data Cloud Summit, is coming up. It's in the first week of June here in San Francisco. And it's a whole week of fun and games and data and AI, tons of fun to be had. But then one big thing, and also the newest thing that's coming up, is that we have a whole day dedicated to all the developer communities out there. So if you're a builder, AI and data and apps and whatnot, it's a free day of free registration. Anybody can come in, and it's jam-packed with tons of different activities. Say you have luminary speakers from different AI companies who've built, and you have LLM boot camps if you want to go learn something and build your skill on specific things. And of course, we have all the other fun that comes with the conferences too, like swag and parties and whatnot. I think that's all I had for today, and thank you so much.